I'm Miss Conley.
And I'm Miss Frost.
And today we're going to be learning about the greatest common factor and the least common multiple.
Miss Conley, do you hear that?
What is that?
I don't know.
What?
Ding, 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 Factor Ninja Warrior Game.
I will defeat you. Victory! I'm the Factor Ninja. I chop up numbers to find their factors. A factor is a number that is multiplied to get the product of another number. So, we were going to look at the number 6. We can find the factors of the number 6. So I know that 1 times 6 gives me 6. So this tells me that 1 and 6 are factors of 6 because they multiply to give me that product of 6. I also know that 2 times 3 equals 6. 2 and 3 are also factors of 6 because they multiply to give me the product of 6. So, because I'm the Factor Ninja, I can chop up 6 and get the factors of 1, 2, 3, and 6 because they all go into that number of 6. So let's look at another one. We will look at 12. So, Factor Ninja, chopping up 12. I know that 1 times 12 equals 12. So 1 and 12 are the factors of our number 12. I know that 2 times 6 equals 12. And lastly, I know that 3 times 4 equals 12. So altogether, I know that my factors of 12 are 1, 2, 3, 4, 6, and 12. So as a Factor Ninja, I can also find common factors between more than one number. So for 6 and 12, if we were trying to find a common factor, that would be a factor that two numbers have in common or that they share. So these are my factors for the number 6, and these are my factors for the number 12. So to find which ones they have in common, I can just look at both lists. I know that they both have 1, they both have 2, they both have 3, and they both have 6. So I know that the common factors between 6 and 12 are 1, 2, 3, and 6. And there's also something I can find that's called the greatest common factor. And the greatest common factor is kind of like what it sounds like. It's the common factor that is the largest between two numbers. So for these two numbers, I know that 6 is the greatest common factor because it's larger than 1, 2, and 3. So the greatest common factor, and sometimes we'll refer to that as the GCF of 6 and 12 is equal to 6.
The video here so that you guys can go ahead and talk about what you think a greatest common factor is.
Hi, I'm Sarah, and I have 16 red flowers and 24 yellow flowers, and I want to make bouquets with the same number of flowers in each one. Can you help me find the greatest number of bouquets I can make?
Wow, Sarah really needs our help creating her bouquets of flowers. We know that Sarah has 16 of one type of flower and 24 of another. So who better to call than the Factor Ninja to help her find the greatest common factor of these two numbers? So there's two different methods we can use to find the greatest common factor of two numbers. The first method is a list method. So what I have to do for the list method is find all the different factors of the given number and then find what the two have in common, kind of like what we did in our last example. So for 16, I know that 1 times 16 gives me 16. I know 2 times 8 gives me 16. And I know that 4 times 4 gives me 16. And because there's two 4s here, I only have to list them once. So So I know that my factors of 16 are 1, 2, 4, 8, and 16, which is my list. So now I'm going to chop up and make 24 smaller. So I know that 1 times 24 equals 24. I know that 2 times 12 equals 24. I also know that 3 times 8 equals 24. And I know that 4 times 6 equals 24. So now I can list out all of my factors of 24, which are 1, 2, 3, 4, 6, 8, 12, and 24. And just like in our last example, I can now look at all the factors that 16 and 24 have in common. So I know that they have 1 in common, they have 2 in common, there's no 3 in 16, so I know that we can move on. They have 4 in common, I see an 8 in common, and that's all the common factors that I see. So now we want to find the greatest common factor to help Sarah find the amount of flower bouquets she can make. So when I look at all of my common factors, I have 1, 2, 4, and 8 in both sides. So I know that 8 is my greatest common factor, so Sarah can make 8 bouquets of flowers. So there's another way we can help Sarah solve her problem of bouquets of flowers. I'm going to continue thinking through my steps out loud and show you a different method that is called the factor tree method. So again, I know that Sarah has 16 yellow flowers and 24 red flowers. So what I'm going to do first is begin making my factor tree. And I'm thinking of two factors I know that make 16. So I already know that 4 and 4 make 16. And when I'm making my factor tree, I know that it doesn't matter which ones I start with, as long as the two factors equal that product at top, which is 16. So next, I know that 4 can be split into 2 times 2, which can be done on both sides. And now I have to stop and think. I know there's something special about the number 2, and I know that the thing that's special is that it is prime, which means that I can't break down 2 any further, because a prime number is something that can only be broken down into 1 and itself. So 2 can only be broken down further into 1 and 2. So I'm just going to leave it just like that. And I'm going to circle any prime numbers that I have at the bottom to help me remember when to stop. So now I'm going to write out my prime numbers at the bottom. So I have 2 times 2 times 2 times 2, which I know gives me that product of 16. So now I'm going to move on to 24. And I'm going to start my factor tree the same way with two numbers that I know equal 24. And I know that 4 times 6 gives me that product of 24, so I'm going to start with 4 times 6. I also know that 4 can be split into 2 times 2. And just like I knew in 16, I can also know here when I'm solving for 24 that 2 is a prime number, so I'm going to circle that. Next, I'm going to break down 6, and I'm going to break down 6 using 2 times 3. And I know that 2 is a prime number once again, and now I have to look at 3. I have to think to myself, can 3 be split down any further than 3? And it cannot, because the only way that I can split down 3 further is by 1 and 3. So I'm going to circle 3 because now I know that 3 is also a prime number. So I'm going to write out all of my factors of 24, which is 2 times 2 times 2 times 3. So now that I have both of my broken down forms of 16 and 24, I know that I have to find what is in common between both of my broken down forms. So I can see that both of my forms start off with a 2. So I know that they have that 2 in common, so I'm going to write that underneath. I can also see that they have another 2 in common, and even another 2 after that. So I can see that 16 and 24 have 3 2's in common. So I'm going to write 2 times 2 times 2. Now I have another 2 left over from 16 and a 3 left over from 24. But since I know that those aren't the same number, I'm going to leave those alone and not include those in the bottom of my problem. So now all I have to do is multiply out 2 times 2 times 2, which I know gives me 8. So I know that the greatest common factor between 16 and 24 is 8. So Sarah can make 8 bouquets of flowers, just like we got using the list method. Okay, now you try. Can you help the Factor Ninja find the greatest common factor, or the GCF, between 10 and 56? So go ahead and solve for the greatest common factor between these two numbers, and when you and your group member or partner are finished, walk each other through the specific steps you took and kind of do a think aloud with your partner or group members to really show them the strategies that you use. And you can pick either the list method or the factor tree method to solve for the greatest common factor. So I'll go ahead and pause this video, and when you are finished with your problem and working with your partner, go ahead and unpause the video. Thanks for helping me chop it up. You should have gotten a greatest common factor of 2. Man, Miss Conley, those factor ninjas were crazy.
You're telling me. I'm sure glad that they're gone.
Do you hear that? What's that? Sounds like someone's casting spells.
Only 2 pencils. Not if the multiple magician has anything to do with it. Multiplicifio! 4, 6, 8, 10, 12, 14. Now I, the multiple magician, have all the pencils. I am the multiple magician, and I have the power to use my spells to make multiples appear. If I wanted to find the multiples of 2, it's similar to skip counting, and I would just continue to count by 2. So 2, 4, 6, 8, 10. 4, 6, 8, and 10 are all multiples of 2 because they are increasing by 2 each time. Similar to finding common factors, we can also find common multiples. So if I wanted to find the multiples of 5, it would be 5, 10, 15, 20. And the common multiples that I have between each are 10 and 10. But we can also find the greatest common multiple, which would also be 10 and 10, because those are the only 2 numbers that each 2 and 5 have in common.
So go ahead and pause the video here to talk about what a least common multiple is with your table partner.
Now that we all know how to find the least common multiple, I think I hear a friend calling for some help.
Hello, I'm throwing a party for my friends, and I need some help shopping. Cups are sold in packages of 4, and plates are sold in packages of 10. If I want to buy the same number of each item, how many packages do I need to buy of each?
My friend needs our help to find the least common multiple between 4 and 10 so he knows exactly how many cups and plates to buy. There are 2 different ways that we can help him solve this. The first way is the list method. Again, this is really similar to skip counting, so when we count for our 4, we can skip count by 4 to find our multiples. So 4, 8, 12, 16, 20, 24. I'm going to go ahead and stop there because this list can go on forever. For 10, we'll go ahead and drag it down here. Again, we'll start skip counting by 10s to list all the multiples. 10, 20, 30, 40, 50, and again, that'll go on forever. But I can go ahead and stop because I already see a common multiple between my 4 and my 10. So I know that 20 is common in each 4 and 10. So that is the least common multiple because that's the first one that we run into. So now that we know 20 and 20 is common in each of them, we know that our least common multiple, or our LCM, is equal to 20. That means my friend needs to buy 5, 1, 2, 3, 4, 5 packages of cups, because 4 cups comes in each package, and two packages of plates so that he has the same number of each item. Another way we can find the least common multiple is using the tree method again. I know that I can break down 4 into 2 and 2. And again, I know those numbers are prime, so I'll go ahead and circle them so I know that I'm done. And when I write that out, it would be 2 times 2, which equals 4. And when I break down my 10, I know that I can split it up into 2 and 5. Again, I know 2 is prime, so I'll circle it. I know 5 is prime too, because it's only multiplied by itself and 1. So when I write that out, it'll be 2 times 5 to give us 10. Now when we're trying to find our least common multiple, we need to make sure we include both parts of our 4 and our 10 in order to find the correct least common multiple. So I know that 2 times 2 is 4, so I'll go ahead and include that down here. 2 times 2, and I'll put a little check mark under each 2, so I know that I've already included them. This equals 4. But I also have to include all the parts of 10. I see that I already have a 2, so I can go ahead and check that off as well, because our 2 is right there. But I do still need a 5, so I'll go ahead and add the 5. So I know that this 2 with the 5 gives me 10. And in order to find our least common multiple, we multiply 2 times 2 by 5. And that'll give us our answer of 20. Now it's your turn. I need you to help me, the multiple magician, find the least common multiple, or the LCM, between 6 and 8. Go ahead and pause this video so you can work through the problem independently, and then share with a partner each step you took. Great job, magicians! You should have gotten the least common multiple of 24.
Remember, I'm the factor ninja and I chop up numbers to make them smaller and to get the factors.
And I'm the multiple magician, and I use my spells to find the multiples of each number.
For your exit ticket today, please find the greatest common factor and the least common multiple between 4 and 12. You may use whatever strategy you would like. Pause the video now and restart later.
Wow, Miss Conley, what a crazy day.
I am sure glad that I did learn about greatest common factor and least common multiple, though.
I am too. Next time those factor ninjas and multiple magicians come around, we'll know what to do.
We sure will.
Hi.